Welcome to Ask and Learn.
This is an interesting problem, and that requires a little bit of thought, or you should put a little bit of thought into how you're going to solve this before starting into things. And why that is because but we're asked to say that uniform. This is so you have uniform books here, so they're weights uniformly distributed. They all have the same length, A, and we want to determine the maximum distance, D. Okay, so here's D. That the top book can extend out from the bottom so that the stack does not topple over. So what we need to think about is, is it, so if we just push the first book off, then obviously it's going to get such that if we keep this one fixed, once that the center of mass of the top book goes past this edge here, then it's going to topple. But the other case is that both could topple over. Obviously, if this one extends out and this one extends out, we'd expect that we could extend it further. So we're going to look at the case of when both books topple over. So now we need to be worried about when this point gets to here and then the total moment falls over, or gets kind of so that these books topple over. And so what we do is we have just forces in the y direction. So F1 is here. All right, so that's kind of when they start to top, when the second book starts to topple over, then there's no distributed load here, and there's just basically a point load where they're in contact. So we just have a point load in the y direction, and I'm going to call this my origin here. So then we have the mass of the second book here, and then the position of that second book from R. So what we need, we have basically this geometry, although it looks simple, gets a little bit complicated. So what we have is we know, I'm just going to kind of go through this. We know R from 2 to 3, so from here to here, is A over 2. R from 1 to 3 is D minus A over 2. So that means that's just actually R3, the position of this vector, or position, and we're obviously only worried about the horizontal position because all these loads are vertical. So we have R13 is D minus A over 2, and that's the same as R3, and R12 is D minus A, so 1 to 2 is D minus A, and that's R2. And so what we can do is then find, we know the mass of the third book, again, and again its position is here, and the mass, the second book is acting here. And so basically what I did to find this is it was easier to find this, and then I took this minus this to get this, right? So all these are related because we form basically a loop here. So it was easier just to find this, and then find this from these two. So, but once we have all the positions, the forces in all the positions, we just basically need to, in this problem, just some moments about this point here. And what we find is that D equals 3A over 4. So we can extend this out about 3/4 of the length of the book. So if this is 3/4 the length of the book, say, we could extend it out quite a ways to here before it falls. And then this basically the second book will be obviously it's going to have its pivot point, or its center of mass, kind of aligned up here. And so we can figure out what the configuration is just by knowing where these vectors are. So if we plug this into here, the third book is going to be at a position of, let's see, this is 2a over 4, right? So this would be out a over 4 from here, and then this one is going to be out let's see here, it's going to be back here about 1/4 a, so it'll be back around here. The center of mass will be back here. So that's the configuration, and so you can figure that out just by using the moment balance here. And then we basically wind up with just one equation, but we have one unknown d, assuming that we're given a.